Hey, what's up?
Hello.
Hey, what's up?
Hello.
Seeing your pretty face when you clicked on our video.
We're 3 students from Mr. Regpala's AP Calculus class at Arvin High School, and our assignment is to research the life and major contributions of a significant mathematician.
In this video, we will be discussing the mathematician Srinivasa Ramanujan.
First, we will be discussing his life and then his contributions to mathematics.
Srinivasa Ramanujan was born in South India on December 22, 1887. He was the child of K. Srinivasa Iyengar and Kamala Tamal. His brother was Sadagopan Ramanujan, and he eventually married Janakyamal.
Ramanujan had a unique academic career compared to other mathematicians. He was a promising student in high school and won academic prizes. He excelled in all subjects. However, at 16, his education took a turn for the worse. After reading a book synopsis of elementary results in pure and applied mathematics, he developed a mathematical fever. This was no mathematical classic, but instead a book typically used to aid students in the Tripos exam, which involved a great deal of memorization. This book was a complication of thousands of mathematical results, which ignited a feverish mathematical activity in Ramanujan. Unfortunately, his focus on math caused him to fail his classes.
As a college dropout from a poor family, Ramanujan faced difficult times. He lived solely off the support and charity of his friends while he focused on filling mathematical notebooks with his discoveries and seeking mathematical patrons. Finally, he found moderate success when the Indian mathematician Ramachandra Rao recognized his genius and provided him his first subsidy, and later a clerkship at the Madras Port Trust. During this time, he published a 17-page paper on Bernoulli numbers that appeared in the Journal of the Indian Mathematical Society in 1911. With the encouragement of friends, he wrote to mathematicians in Cambridge to seek validation in his mathematics. Twice he wrote with no response, but on the third time, Hardy responded enthusiastically.
Hardy's correspondence with Srinivasa improved Ramanujan's status immediately. Srinivasa Ramanujan was named a research scholar at the University of Madras. At this position, he received double his clerk's salary and only had to submit quarterly reports on his work. However, Hardy was determined that Ramanujan go to England despite Ramanujan's family's vocal opposition. In March 1914, Ramanujan headed for England.
Ramanujan's arrival at Cambridge was the start of a successful 5-year collaboration with Hardy. Despite being an odd pair, Hardy was instrumental to Ramanujan's growth. Hardy, an established, well-known mathematician, said about Ramanujan, "I have never met his equal and can only compare him with Euler or Jacobi."
The full result of the Hardy-Ramanujan collaboration is described on the United States Naval Academy. According to an article on the United States Naval Academy, a partition of a positive integer n is just an expression for n as a sum of positive integers regardless of order. Thus, p of 4 equals 5 because 4 can be written as 1 plus 1 plus 1 plus 1, or 1 plus 1 plus 2, or 2 plus 2, or 1 plus 3, or 4. The problem of finding p of n was studied by Euler, who found a formula for the generating function of p of n, that is, for the infinite series whose nth term is p of n x to the nth power. While this allows one to calculate p of n recursively, it doesn't lead to an explicit formula. Hardy and Ramanujan came up with such a formula, although they only proved it works asymptotically.
This discovery led to the mathematical recognition beyond Hardy's approval. If it were not for Hardy's conclusion that the results and formulas in Srinivasa Ramanujan's original letters must be true because if they were true, no one would have had the imagination to invent them, Ramanujan would have not been able to achieve a bachelor from Cambridge in 1916. This degree was granted for Ramanujan's research. In 1918, Srinivasa became the first Indian to be selected a Fellow of the Royal Society.
Ramanujan had strict dietary rules to try to improve his health. He was hospitalized in 1917, which caused many people around him to fear for his life. In 1918, he finally recovered, but his health failed again, which caused him to die the next year.
Despite his premature death, Ramanujan left behind an impactful mathematical legacy. Besides his published work, he has left behind several notebooks which have been the object of much study. Several mathematicians, including the English mathematician G.N. Watson and more recently the American mathematician Bruce C. Berndt, have written multi-volume studies about his notebooks. In 1997, the Ramanujan Journal was launched to publish work in areas of mathematics influenced by Ramanujan.
Thank you so much for watching our video. We hope we have provided helpful insight into the life of the mathematical genius,
Srinivasa Ramanujan.